Hello YouTube vintage stereo collectors and restorers. I'm just answering, I've had some questions lately about, in particular, this Kenwood board here. The one that has 6 potentiometers on it. It's the driver preamp board, and it's in the KA2000, KA2000A, KA2500, TK150, TK250, TW61. The KR33, a similar version to it in a KR2120, 3130. What is the board actually called on the schematic? The 8215 board, that's right. And what it comes down to is setting these little potentiometers that we've replaced with the blue burn pots, which are much more stable. This has been covered, which pots to use on another video. But I'm going to talk today specifically about which ones to turn and what values to look for on a meter. The unit's on. And all I really need is my multimeter, good digital multimeter. So I'm just going to run through it a bit and hopefully you can see it well enough. So it's on, it's idling, I have some headphones in, a source from a tuner. Just a couple voltages to check as you're going along. The main filter cap is at 39.940. And then it's dropped down to 22 and dropped down to around 20, 19 or 20, which goes to the preamp stages. This is the bottom of the board we're talking about that has the 6 potentiometers on it. And so the first one I want to show you is bias. To set the bias, see the 4 resistors here, emitter resistors on the outputs? Some of them are gray, some of them are this color. There are 3 different kinds I've seen in here. They're 0.47 ohm. And what I do is, providing that the output transistors are working, I go for a low scale in the millivolt range and make sure you're grounded on the chassis. And see, these 2 resistors are grounded here. You clip on the other side of the grounded resistor. 6.8 millivolt. Okay, that's not bad. I mean, I just put the pots in, I haven't even set them up yet. So I'm going to make sure that's not touching anything. I'll turn this around sideways so you can see the meter, and I'm going to go on the corresponding pot. And this is where it gets a little bit weird, okay? This I'm going for is VR5 for where I'm clipped on. This is a bias pot. So I'm just going to set it around 12. 14's about right, but it's warming up. And just so you can see which one I turn, it's that one. Then for the next bias pot, we'll be doing that one. And so for the next bias pot, I'm going to carefully clip on here. Make sure that when it turns around, that can't hit a screw or anything, you know. So we're about 7.8. And what I did is I took out the old pots and measured what they were and set the new ones to the same setting. So it's fairly, you know, in a fairly good range. Then I'm going to set this one, that's a little higher, about 12. Yeah, about 12. While it's warming up, it's been running about 15 minutes already, but I have this on here so I can slide around a bit better. Now, so we've done the bias, and what you'll find is, good way to tell if the transistors outputs are working, the next emitter resistor, which is not to ground, but is to the center voltage pin, should give you, say, 11.4, 11.5. If that transistor is working, the reading should mirror the one you just set, 12.6. So output transistors are working, they're slightly turned on like they should be. Now I look at center voltage. So first I'm going to show you where you read those from. And that's where this speaker cap connects on to this lug here that has several other things under it. It's basically the case, the collector case of that transistor. So that's sort of the center line, the 0 volt, but it actually really isn't 0 volt because it's biased. So we go set to a higher reading, 200 volts. So that should be exactly half of what your main voltage is at the main filter. It's 39.7 and we're 19.9. That is so close I wouldn't even turn it. Okay? But I'll show you which ones to turn when I get top side. This one here's a little hard to get to. 19.9. I just set them at the midpoint of what is that in there? 20K potentiometer. So those are actually okay. Center voltage, once they set bias, it's almost automatic. It will be pretty close. I'm just going to show you here. Back at this board. So that's bias, VR5, VR6, center voltage, VR1, VR2 over here, corresponding to that half of the board and that half of the board. The tricky one is the protection level. That's these two here, VR3, VR4. There's very little on the internet about that. But we're about to add something. So what I figured out in my notes, and you can figure out my notes, it's actually 530, around 530, 540 millivolt. I find it's about right, and this is just a trial and error thing. And where I'm actually measuring, okay, this is the protection transistor right here. And from one channel, we get from the collector side through VR4, through that diode, and up to the base of that transistor. This one's over on this side. It goes through DE1, which is on that side. And this one is a little hard to get to. On the underside here, it's this spot and this spot, which is just past the potentiometer, the 10K potentiometer. So you can't really clip onto that very well. Maybe we'll bring this around this way. You get a good view of it. Some light on it. So there's the board. I haven't finished recapping it, but I've done enough so I can set it up. Oh, it's playing so nicely. Almost makes me wonder if I should bother recapping that. Just once I've done those main caps, it really perked it up. So what we have to do, you'll see D1, D2 right there. It leads over to the protection diode. Hoping you can get a good view of this. VR3, VR4. So go on the lowest scale DC, like this is the 200 millivolt scale. Sorry, the next one up 2000. I was thinking of another meter I have. Clip on the ground. Very carefully touch that one. Oh, I'll make sure you can see this. So for this protection right here, I'm touching there. 518 millivolts. This one. 525. They're really close. I set them to what the original pots were. Sometimes you can clip on to here. It's not easy. But since we have the bias right, I need to put something there so this doesn't slide. I hate when stuff slides and goes flying off the table. So, we'll get a little screwdriver. And I want to try to do this so you can see it. I don't really have enough to clip onto there, so I'm just going to try to get it. No, it's not enough. Well, okay, I got it. So I'm going to bring this up to 5. Yeah, let's go 530. What this is feedback from the output stage. It's basically DC voltage from the output stage. When it's correctly biased, you get about 530 millivolts a channel. And then the turn-on point for this transistor to activate the protection circuit is 610 millivolts. So there's a little bit of an area here, so you can now turn it up. I've got it running about, I can hear it blasting on my headphones. That's not going to rise very much because you're not clipping. This is only looking at DC voltage. Now I'm in on that one kind of. Well, that one's almost right on, so. Touchy! 530. That's D2 and VR4. And so then what happens is it conducts forward with those two germanium diodes on this filter capacitor, so they're joined. If either channel goes into clipping, you get a square wave type of thing happening with the outputs, which means they're reaching overdrive. It will actually turn on this transistor. I'm going to change this one, it's a C458, and it will shut down the DC voltage that runs the entire board. It shuts down the preamp, so then the circuit falls and you're out of clipping. And what will actually happen is, in real life, when you turn it up, you're blasting some music, you turn it up and it hits clipping, it doesn't really, you don't really hear a shutdown, it just sort of reduces in volume, it sort of just fades down, and no matter how high you turn it after that point, it doesn't go any louder. It's a feedback circuit that just basically keeps it from self-destructing. And well, I just hope that's helpful. That's in response to somebody that had a question about this, and it's actually a question that comes up all the time. I thought I'd show you how to do it. I've never had these diodes go bad. They're always good, because that's not a lot of voltage on them. And they need to be germanium diodes because of the low turn-on voltage. They turn on around 200 millivolts, so you're long past that. If they were silicon diodes, you'd have so many turn-on points in the circuit, it just wouldn't work right. But thanks for watching and listening.